In the last video, we saw that the proportion of athletes that took less than 100 minutes to complete the race was 0.877. That means that if we randomly select an athlete from all the athletes, it was actually 224 athletes. So if we make a random selection from the 224 athletes, the probability that we pick an athlete that completed the race in less than 100 minutes is 0.877. This means that the probability that a randomly selected athlete took more than 100 minutes is going to be 1 minus 0.877. Because there are only two options. Either an athlete completed the race in less than 100 minutes or more than 100 minutes. Well, strictly speaking, we should probably say greater than or equal to, just in case some athlete completed the race in exactly 100 minutes, which is highly unlikely. It's too precise a time, considering that this race, the timing in this race involves thousandths of a minute. But anyway, we will need this probability in this question. For this we get 0.123. It's actually the area under the remaining part of the normal distribution, because the total area under a probability distribution is 1. After the event, a reporter wants to interview two people who took more than 100 minutes to complete the race. She approaches athletes at random and asks them their finishing time. She keeps asking until she finds someone who took more than 100 minutes, interviews that person, and continues until she finds a second such person. Assuming the athletes are cooperative and truthful, what is the probability that the second person she interviews will be the sixth person she approaches? So we are interested in the probability that out of 5 people she approaches, one of them took more than 100 minutes. Well, exactly one of them took more than 100 minutes. So let's let capital X stand for the number of interviewed athletes out of the first 5 athletes that she meets. We are interested in the probability that X equals 1. So one athlete gets interviewed. In other words, only one athlete out of the 5 had a completion time that is greater than 100 minutes. So in general, the probability that X equals R is NCR P to the power of R times 1 minus P to the power of N minus R. X follows a binomial distribution. The letter R is often used, but it probably will be more consistent with general notation to use little x here. So a capital letter stands for a random variable, and little x is a particular value of the random variable. So often I use little x just to be consistent with the letter that I use for the random variable. But it doesn't matter, of course. It's R in many tables, but I'm going to call it x. It's only a letter. So little p, which is 0.123, is the probability that an athlete approached is interviewed. In other words, it's the probability that an athlete that is approached has a completion time greater than 100 minutes. So we just fill in the values. We want just one athlete interviewed out of 5 athletes, where the probability that any given athlete is interviewed is 0.123. So we need to calculate this. To 4 decimal places we get 0.3638. So again, this is the probability that out of the first 5 athletes that the interviewer approaches, exactly one of them has a time greater than 100 minutes. So exactly one of them gets interviewed. The other 4 are not interviewed. So that's the situation for the first 5 athletes approached. But we also know that the second person she interviews is the 6th person that she approaches. So now we're interested in the probability that the sixth person approached is interviewed. Well, that's just the probability that any athlete approached is interviewed, which we know is 0.123. So we have this extra condition. It is not enough that exactly one out of the first 5 athletes approached is interviewed. We also want that the sixth athlete approached is interviewed. So that will reduce this probability, obviously, because we have this extra condition, extra constraint. So what we do is we multiply these probabilities to get a smaller probability than 0.3638. We certainly don't add them. If we were to add them, we would get a greater probability than 0.3638. We are dealing with independent events here, so we multiply the probabilities. So the probability that the sixth person approach is interviewed does not depend on the situation for the first 5 athletes approached. It's completely independent of that situation. So for independent events, we multiply the probabilities. We get 0.0447.